Alrighty. Alright, I think we're ready for number 13. It says sketch 1 period of this guy. Okay, so first thing I'm going to do is go ahead and draw in my midline or my vertical shift, which is going to be at y equals 1. And then I'm going to note that my amplitude is what? 2. So I'm going to have to go up to 3 and down to -1. Would you agree with that? I like to get those marked because remember, the sine or the cosine is going to have maximums and minimums, and that's where they're going to happen. Okay, now, what does this tell me right here? That's where I'm starting. So whatever's happening starts happening at -pi/3. Agreed? Now, it's a sine curve. So where does a sine curve start? On the midline. So at -pi/3, I'm on the midline. There's the first point of my graph. Is everybody with me? Okay. Now, I need to know what the period is. So I'm going to look over here at my equations. Period is 2 pi divided by b. So my period is 4 pi. That means that my curve is going to end exactly 4 pi after it starts. So if it started at -pi/3, it's going to stop at 11 pi/3. Period is its length. Start here at 4 pi. Now, what happens to the sine curve at the end point? It's on the midline. Now, halfway in between would be what? -1 to 11. Halfway in between is 5 pi/3. And with a sine curve, isn't that also on the midline? Now, halfway in between these guys, -1 and 5, halfway in between is 2. And what happens to the sine curve there? That's a maximum, right? Positive sine curve. Halfway in between 5 and 11, 8. And that is my minimum. And then I can connect my dots. Connect my dots. And there is, not too good, but there it is. Okay. All right. If the minimum of a sine curve, okay, we're good on this one? Lost space. All right. If I have a sine curve, and the minimum is at pi/4, -1, and the maximum is at pi/2, 3. So my curve looks like this. Find the period, amplitude, frequency, and midline of the curve. So period, amplitude, frequency. Okay. Well, I think the midline is an easy place to start because it's right in the middle of all this. And in fact, it's the two numbers I had just a second ago, because what's halfway between -1 and 3? 1. So my midline is y equals 1. Now, if that's y equals 1, then what is my amplitude? 2. Now, max to min, whether it's a sine or a cosine, max to min is half a period, right? It's half the picture. So, how far is it from the minimum to the maximum? Pi over 4. So that's got to be doubled. So my period's pi over 2. And if my period is pi over 2, then my frequency is 2 over pi. Using calculator regression, find the minimum value. Okay, so remember, once your calculator has a graph, it can locate a minimum just by using the minimum button. So let's go ahead and do that. And actually, you don't even need to graph it, do you? Because once you have the equation, can you find the minimum? You'll know your midline, and you'll know your amplitude. Can't you find your minimum just using those numbers? So if you don't want to actually graph it, you don't have to. Tell me what you got. Right off to 1,000. Oscar, math is not a spectator sport. Kathy, you got it? What you got?
I got 4.991.
4.911.
I got 991.
991. Oh, wait, for your answer?
Mm-hmm.
What did you get for your equation?
Oh, I got 3.117 sine 0.556 plus 0.959 plus 8.108.
Okay, I don't know if I kept up with you or not, but does that look about like what you have? Let me see if that's what I got when I did it. Yeah. So then, you're looking for the minimum. So what do we know about this curve, guys? We know that the midline is at 8.108, and the amplitude is 3.117. So we're going to go 3.117 above that number and 3.117 below that number. So did you subtract those? And what did you say you got? 4.991? Good, so did I. Anybody have a question about that? Now notice, always, guys, when the calculator does the regression, it looks like this. It's going to come out that way automatically. If you need a phase shift, then you need to factor out that 0.556. Otherwise, you don't need to worry about it. It doesn't matter. It doesn't have anything to do with amplitude or anything. But if you need to know, if it says, what's the phase shift of this function, then you would need to factor out the 0.556. Okay? Factoring's division. So basically, you're just going to divide it out. Okay. All right. And then the last problem is, of course, one of these big giant things that we had done several of. All right. All right, take a second, get your bearings. Tell me some stuff you know. What's some stuff you know? Have you figured out any points? F=0.14. So what she's saying is, at time 0, we are 14 feet from the bush. Is that correct? And she put it up there because isn't 14 going to be the maximum? Isn't that the farthest we can be from the bush? So if you were doing this on a coordinate plane, that would be the top point. Okay, when do we have another one? What's P going to be? 3:14, because the thing goes around once every 3 seconds. So its period is 3. Well, what does that make this one then? At least, what does it make this X? 1.5. Now that would be the closest the merry-go-round is to the bush. So that would be what? 6. And you know it's 6 because the radius of the merry-go-round is 4. Okay. All right. Well, what about this guy? He's going to be halfway in between, so that would be 0.75. And what's his Y? 10? Does that make sense to everybody? Good? And then how about K? K would be 2.25 10. Feeling more confident about that kind of stuff, right? Hopefully a little bit. All right, so we refer to the graph, the t-coordinate of F. So we're looking at F and G. So we're looking at F and G this time. On the interval from F to G, which of those statements is true about the function, about the curve itself? Which one is true? Yes, positive and decreasing. Remember, H refers to the y's. H is the function value. Those y's are positive. If you were graphing, it would be up here like this, right? It's positive, but it's going down, decreasing in that interval. How about the rate of change? What's happening to the rate of change? Well, it's negative and it's negative because it's going down, slope is negative, and it's decreasing because it's concave down on that interval. And then we have to write an equation for this, and it's a sine equation. So we're going to write a sine equation. Well, the amplitude is 4. I know my midline is 10. Now what's what's the period? We said the period was 3, right? So 2 pi over b, that's b. 2 pi over it has to be 3. So it looks like b is 2 pi over 3. Is that okay with everybody? And now I need a phase shift. Well, if this is going to be a positive sine curve, I can either start back here, in which case I'd have to figure out that point, which I'm a little uncomfortable with because that would be a negative time. Or I can just skip over here and start right there at a point that I know, and that would be x minus 2.25 because it's phase shifted to the right. Good? Okay. All right, now we will start the second review that I gave you. I'll let you go through and pick out what you want to do on the second review. But first, let's take care of any questions from homework that you have. Yeah.
On the 3.7 homework, could you do number 4?
3.7, number 4. What's happening here? Okay, so okay, so I need to make sure. I don't think I put here. That this is tied to the x coordinates. There was a problem like this in our notes, and I think I didn't type it completely. So it's going to be tied to the x coordinate. So at time 0, the yo-yo is at 0. And then it's at 0 again when? How long does it take it to get around? In 5 seconds, assuming it's seconds, it does 30 rotations. So in 1 second, it does 6. So it's back around at a 6. Does that make sense?
Mm-hmm.
Okay. So, okay. So then where is it at? Let's see. Halfway would be at 12. When the yo-yo is up at the top, what is its y coordinate up there? It wouldn't be 30. Oh, no. It's distance. Its distance would be 60.
Oh, yeah.
Okay, so I need a sine curve. And I know I got a point at 0, 0, and a point at 1, 6, 0, and a point at 1, 12, 60. Okay, well, where's the midline in all this? Oh, wait a second. No, that's not a midline. I gotta be careful here because my equation has to be in this form. So there can't be any vertical shifting or horizontally shifting. That doesn't really make sense then. Oh, no, I think you were right when you said, because I'm looking at y coordinates, so it'd be 30 and negative 30. Yeah, there we go. There we go. 1.6 was 0, right? So, this is what it looks like. Okay, so the maximum is somewhere between 0 and 112, and the minimum is somewhere between 112 and 16. Does that kind of make sense?
Yeah.
So what do I know about this curve? I know its period is 1/6. So 2 pi over b has to be a 6. So b is 12 pi. And I know its amplitude is 30. And that's all I need. Because they tell me there's no shifting involved. So what I did, I need to rewrite that problem to make sure you know that the x coordinate is the time and the y coordinate is the distance from the starting, or from, I need to rewrite that problem. Don't worry about it, because now that doesn't make sense if that's, oh, that's not 60, that's 30. No, that's 0. See, now I'm getting myself all screwed up. I think this is supposed to be the this is what happens when I write problems. I'm not Mr. Passwater. So I think that's supposed to be the x coordinate. I think that's supposed to be the x coordinate. So at the bottom it's 0, at the top it's 0. And on the first time around at 112, or no, that's the bottom, the top. This is the top, this is the bottom. So at 1/24th, it would be on the right, and that's 30. And at 3/24ths, it would be on the left, and that's -30. Yeah, so that's the way your order pairs are supposed to be set up. Okay, so I need to clarify that, I didn't. Okay, what other mistakes can I find? Yes, Bryce,
Maybe number 2.
on the same homework? Okay, did you get a regression equation?
Yes.
Okay, what was your equation?
Oh, I don't have it.
Well, I'll just tell you what I got. I got, 3.118 sine 0.570 x minus 2.229 plus 15.792. Okay, so I don't know if that's right or not, but let's just go with that to answer the question. Okay, so what was this? This was the number of daylight hours. Okay, so I know my midline is at 15.792, and my amplitude is 3.118. So the maximum daylight hours, this is maximum day, is going to be 15.792 plus 3.118, and the minimum day would be the same thing, only minus. Does that make sense? Okay, so what does the question want to know? What is the minimum number of nighttime hours? Okay, when is that going to happen? When are you going to have the minimum number of nighttime hours? When you have the maximum number of daylight hours, right? So whatever this is, 18, 19, it's got 19. If you have 19 hours of daylight, then you'll have 5 hours of night. Does that make sense to you? Okay. Who else? Anything from any of the papers? All right. Then take a look at this second review And we're obviously not gonna have time to do the whole thing. So while you are looking at it to pick out which problems you want to do, I am gonna hand back your last quiz for you to look at that too, and you will need to turn this back in, okay? So you'll need to turn this one back in. I can't remember how much it was worth, but I want you to figure out what you did wrong. Must have been a little 15 because Sandra got an explanation. And so did Emily. You can mark on these, you can try to correct your error, whatever, but this time I do need it back. Please. Make sure I get it back. Fire Bryce.
Obviously in
Okay, guys. What have you found? Either on the quiz either on the quiz or, review sheet, yep. On the quiz, which one? 3B, we're finding where the tangent is 0. So remembering the tangent is y over x, and visualizing my unit circle, where is it that if I put y over x, I get 0? Here. So the answers would be, in one revolution, the answers would be 0 and pi. Now, some of you put 2 pi down there, and again, you gotta pay attention to your directions. They're gonna be pretty consistent through all of this. We're gonna start solving trig equations. That's gonna be pretty consistent. So 0 is your answer, not 2 pi, unless for some reason the directions have changed. Okay, anything else, either on the quiz or on a review sheet? Let's do the quiz first, then get this collected, we can go to the review sheet. Anything else on the quiz?
Ms. Gordon,
Mm-hmm.
I went over this with you like after I took it, but so for co-terminal, I was on the review too when I wasn't here Friday, but it's that it was like
Okay, so Oscar, let's clarify something. When you're not here, watch the video. Okay, that's what we do. Now, I'll answer your question, but being absent is not an excuse for not knowing. Okay, so how do we find coterminal angles?
yeah, but so on the review there was 2 answers and it was like -40 over pi over 7 or -40 pi over 7. Like I was able to get one of them because I added 2 pi.
Well, you can add another 2 pi. I don't know what the directions were. You can add another 2 pi, or you can subtract 2 pi. Adding and subtracting revolutions.
Okay.
You can go either way. You can keep going. So if it says give me a positive and a negative, I want to add 2 pi and subtract 2 pi. Right? If it says 2 positives, I'll add 2 pi and then add another 2 pi.
What is the correct answer?
I don't know. I'm looking at somebody else's answer. It would be -3 pi over 7 plus 2 pi. So -3 plus 14, 11 pi over 7. All right, anything else from the quiz? I'm gonna pick those up and we're gonna get to that second review. All right, and we're gonna pick those up and then let's have some review questions in that second review so I can check some of my answers and see if they're right or not. Okay. All right, here we go. Who's got a question? Did I get all these? All right, who has a question? That you found maybe they're not quite sure of on the review sheet. The one that says review and some. Drew?
We do 6, please.
6. The function is defined, find Q of pi over 3. Okay, do not be frightened of this. How do we evaluate functions? What does it mean to find Q of pi over 3? It means take out the variable and put in pi over 3. So 2 minus 3 sine 2 pi over 3 plus pi over 2. So we're just going to evaluate that. All right, so let's start in the parentheses here. What is that? Common denominator, 5 pi over 6. 2 times it would be 5 pi over 3. You know this. What's the sign of 5 pi over 3? It's a pi over 3, but it's down here. So negative 3 over 2. So 2 plus 3 root 3 over 2 would be as far as we could go without a calculator. Yep. Got it? All right, who else found something that was a bit perplexing? Or you think you need extra practice on it? I'd like to look at number 4. If you don't ask, I'm just gonna start rattling things off, because we don't have time to waste. So I'm gonna look at number 4. And what I want you to think about in number 4 is what this looks like, because you are being asked, when is it increasing and concave down? And you know, every sine function has a spot like that. But let's talk about this for a minute. What does this look like when I graph it? Well, it's got a midline at 1. There is no phase shift, so the sine is going to start here and end here and have a midpoint there, right? It's got an amplitude of 2, so I'm going to go up 2 and down 2. So would you agree that the picture is going to look something like that? Okay, so now I need to know what these labels are. Well, what is the period of this thing? Pi over 2. So the whole shebang is pi over 2. So the midpoint here, you know, one hill, one valley, the midpoint here would be pi over 4. The max would be a pi over 8. and then would be at 3 pi over 8. So 1/8, 2/8, 3/8, 4/8. So now you have your intervals. So now you figure out, okay, where is it increasing and concave down? Well, isn't that this little stretch right here? So what is your interval from 0 to pi over 8? Where is it decreasing and concave down? Well, wouldn't that be this little interval right here? So pi over 8 to pi over 4. And your intervals are open intervals. So you're saying 0 to pi over 8 and pi over 8 to pi over 4. This is A and this is B. Is that okay with everybody? Okay. Have you found anything else, or shall I pick another one? Yep, Julia?
Number 2.
Okay, so it's got a midline at 1 again, and an amplitude of 3. So 2, 3, so up here at 4, and down here at -2. It's a negative cosine, so it's gonna start at its minimum, which is gonna happen at negative pi over 7. So I'm gonna go ahead and put a point there. And I know it's gonna go up and come back down, it's over there somewhere, it's gonna end at that same spot, right? So to find out where that is, I will find the period. So the period is 2 pi, 2 pi divided by 1/5. So the period is 10 pi. Now, that does not mean that I'm ending, I gotta stay on video, so I can't get out there too far. It's actually out there quite a ways. I'm not ending at 10 pi. I am ending 10 pi from where I started. So where am I ending? Now you've got the right idea, but you need a common denominator. So that's 70 pi over 7, right, Quinn? So aren't I ending at 69 pi over 7? So starting there, ending there. All right, halfway in between these two, and again, my scale is completely whopper-jawed, but halfway in between those two is the maximum. So -1 to 69, half of that would be what? 34. For those of you that are confused, she's midpointing, averaging, find the average. -1 and 69 to 68 divided by 2 is 34, good. And then, okay, so that's my maximum. Then I need to know where I cross my, this scale is crazy, where I cross my midline, which is going to be halfway between -1/7 and 34/7. Now this is where some of you just gotta calm down. You can do this. What do you get when you add these two together? 33 over 7, right? Take half of it. What do you get? 33/14. No complex fractions, no decimals in a fraction. You write it as a fraction or a decimal, but not the combination. All right, now do the same thing here. I'm going to add these. What do I get when I add those? 34 and 69. 103. And that's 103/7. So half of that would be 103/14. So now what are the questions that are being asked? I need period, already found that. I need frequency, that would be 1/10 pi. Amplitude is 3, positive, 3. I know it's upside down, but the amplitude is positive. Midline is 1, and phase shift is -pi/7. Julia, is that okay? All right, who else found something? Yep, Xander? 9. 9 is a blast from the past. I'm starting to throw some review in because we're getting about to that point. So 9 says, all right, 9 says, given this piecewise function, find h of -1. Okay, so the first thing your visualize have to do is look at the function, the way it's defined, and which row of the function, which equation of the function has -1 in its domain. The third one. So you're gonna plug it into the absolute value of x, and you're going to get 1. So h of -1 is 1. Then you're gonna find h of 1. Well, which row of the function is 1 in the domain of? The middle one. So your answer is e to the first plus 1. Okay, so you've got to pay attention to what the domain is in that piecewise function, what x is. All right, anything else? Since we had some questions, number 10, 319 pi over 11. Find the smallest positive coterminal angle. Now, normally, when we start with a regular angle, this thing's big. We start with a regular angle, we find a positive coterminal, we add 2 pi. Well, this is too big. If I want the smallest positive coterminal, don't I have to shrink this down? So, I'll just take 11 into 319. Oh, wait a minute, is it going evenly? Right, so that's 29 pi. Well, how much of that do I want to take out? Remember, coterminal, we're doing revolutions. So how much of that am I taking out? 28 pi, so what's the smallest coterminal angle? Pi. Pi. Yep. Don't be confused by 11. You know how to do this. It was on that quiz that I just returned and recollected, except now you're multiplying and adding in it. So 3 times the cosine of -7 pi over 6 plus 4 sine 4 pi over 3. So this is nothing new or different. What's the cosine of -7 pi over 6? So I always have to visualize it. So negative goes this way, right? So it'd be up here. It's a pi over 6. Cosine, so -√3 over 2. So 3 times -√3 over 2. So -3√3 over 2 for part 1. Now part 2, sine 4 pi over 3. Well, that's down here. It's a sine -√3 over 2 again. So that's -4√3 over 2. So the answer ends up being -7√3 over 2. Okay, so don't be confused by that. So that's in there. Threw a couple of log exponent things in there. We okay with 12 and 13? 14 is another sketch. Range. Range is easy, don't make it hard. Don't waste time graphing that thing. Range, it's just the distance from here to here, right? So if you know your midline, and you add, you'll get your maximum, subtract, you'll get your minimum. So it's like twice the amplitude. Just find those numbers, you add and subtract from the midline. 16, where I give you a sine and a cosine and then ask you some stuff. I would rewrite A. You don't have to do this, but it's easier for me to rewrite it. What happens in a sine if you add 2 pi? Nothing. So this is just the same as the sine of negative x, which is negative sine x, because sine is odd. So the answer to that one would be positive 1/3. Okay, and then, how about cosine x minus pi? Where is this angle? This angle is in quadrant 3. How do I know? Sine and cosine are both negative. So if I subtract pi from them, here's x. Where do I end up? Quadrant 1. And the cosine will be positive, 2√2/3. And then here's my original. If I add pi, it's the same as subtracting pi. So that sine would be 1/3. But I'm timesing it by 2, so that would be 2/3. Does that make sense to everybody? Good? Alright, where did I skip? Anything? There will be one problem on the quiz tomorrow where you use a calculator. And you know which one that is, right? That's your regression. So there'll be one problem. The rest of the quiz is no calculator. Julie?
Will there be like these longer review questions on the quiz?
Could be. Could be. May 13th. May 13th. We're zeroing in. Getting close. Not a lot. I'll sprinkle maybe 1 or 2 in. And I won't sprinkle in anything that hasn't been reviewed on the review sheet. Okay? All right, well, you know what you need to do then to get ready